Let's continue with 8a.2.2 De Mor's theorem using an example where we are going to find z to the power of n. And I took this from Patrick GMT, and this is the link where you can watch him explain this the same thing as well. He gives us z in this form. So this is a rectangular expression, root 2 plus root 2i to the power of 5. So n is equals to 5, and this is a rectangular form. It's nice if you go and draw a picture of this z first in the Cartesian coordinate. So this is the real part of z, and this is the imaginary part of z. And this, of course, is the real number, root 2 here along the real axis, and root 2 also along the imaginary axis. Alright, then of course we want to express it in the polar form, so we can calculate the modulus, and the modulus is nothing but the hypotenuse, the length of this vector, which is the Pythagoras theorem, root 2 square along here, and plus root 2 square along here, square root. So the answer of the modulus is 2. And what about theta? Well, basically tangent theta equals to opposite, so this value, the opposite over the adjacent. So this is opposite, and this is the adjacent, and tangent theta is equals to, because these values are the same, is equals to 1, and arctangent is pi over 4. Okay, so this is in radian. So we now can write the expression as 2ej pi over 4. That's how I like to write this. To the modulus, theta is this. But of course you can write it in as well as the polar form in the trigonometric polar form. So 2 is the same as 2. ej theta is made to become cosine pi over 4 plus j sine pi over 4 here. And this whole thing bracket, the 2 comes now. So this expression is this expression. He uses I uses j, but it's the same thing. Okay, so learn how to interchange I and j for complex numbers. Now, remember that we now get this form, and we say that we want to exponentiate by integer 5. So what we do is that we move, remember we use this equation over here on this. Zn is Rn, where z is equals to r. So n is being pushed into exponentiate with r, and n is also being pushed into the angles of cosine and sine. So that's it. So the originally was pi over 4 here, and we are now pushing the 5 into the angle as well as the modulus. That's all about De Mor's theorem. And now 2 to the power of 5 is 32, and the angle you can now work it out and simplify it. This is actually the answer, but if we want it to, instead of the polar form with cosines and sine, we want it to be in rectangular form, it will be this answer over here. Okay, and it's nice to draw what is this value in the Cartesian coordinate again. Okay, so this is the example of De Mor's theorem by Patrick GMT. Thank you.